So here I'm going to have all these folders, all these vendors flying around here. Oh goodness, what am I going to do here? So let me get these guys out of the way. Let's do acetone first, okay? Let's actually take both these columns from acetone and we'll put them here. Okay, this is stupid, I know. But there's acetone, right? So instead of intensity here, I'm going to write acetone, right? Now I'm going to take this one, I'm going to close it. Now for B, let's use Anthony, no slashes, David. Anthony, David, unknown. Well, let's assume this one's toluene. We'll see in a second. I'm going to take the intensity column, copy the intensity column, paste it here. Okay, now I'm going to say, instead of intensity there, I'm going to say toluene and then ethyl acetate. Oops, this one's messed up. Oh well. I think it's okay though. I think it's okay. C. Control V. Say ethyl acetate. And then lastly, we'll do the unknown. Okay, there's the unknown. Control C. Control V. There we go. So intensity, we're going to write unknown. Alrighty. Okay. So now let's go ahead and make a graph of these guys, right? So you'll notice that I trashed the wave number column from these guys because they're all the same. That generates the same wave number column, the same X column every time. So to make a graph of this, it's possible that I could do something clever like this, basically highlight the whole mess. And let's see what this does. We can do data, insert, chats, scatter straight lines. Let's see what this guy looks like. Oh yeah, that works. Yeah, there we go. Cool. So that's actually a good chart to start with here. Now the choice of colors is absolutely insanely ridiculous, right? And also the choice of wave number limits is a little bit insane as well. There's a couple of reasons. First of all, this peak at low wave numbers is probably some sort of artifact. I think this one's probably toluene. And but I'm just going to cut us off here right around, let's say 100 wave numbers. So we go down to 125, right? 125, then I'm going to come up here to 1825. So 125 to 1825. Oops, 1825. There we go. So that looks a little bit less congested. Okay. Let's see now. Toluene unknown. Toluene and unknown look pretty similar there, but oh well. So the title we're all right here is all right. Raman mixture analysis. Okay. so we'll leave that there for the moment. Now let's go ahead and do the analysis, right? Now what we need is we need a linest, and what we're looking for is a coefficient for acetone, toluene, and ethyl acetate that best matches the unknown, right? So we're going to look for a combination of acetone, toluene, and ethyl acetate, which, when added up and multiplied through, best matches the unknown spectrum there, right? So let us work on that. So let us take 1, 2, 3 columns, one for each coefficient that we want. And do we want an intercept? No, we don't want an intercept. An intercept would add a constant offset to the mix, and that's not going to be helpful to us, right? That would be sort of a non-physical thing, right? So I don't actually want additional statistics on this, right? So I'm just going to get the coefficients and the uncertainties here. So that's going to be coefficients and uncertainties. And they're actually going to come back at us: acetone, ethyl acetate, and toluene. So watch carefully. Equals linest. The y value is going to be the unknown. And I do shift control arrow down there from the top, right? I'm going to put a comma. Now the x values are going to be the acetone, toluene, and ethyl acetate columns. Now x in this case does not involve wave numbers. X is what you multiply the coefficients by. Okay? So I highlighted the top row. Now I'm going to go shift control arrow down, right? Now I'm going to say false and true, because I actually want the uncertainty in the coefficients there. So shift control enter. Now I'll slide on back up there. And there's our coefficients, and let me put their names on them. This is acetone, toluene, and ethyl acetate. Right? And these are actually, coefficients are pretty good there. So if we look at this guy, I'll trim the sig figs until we get down to, say, 1 sig fig in the uncertainty there. Right? Right? So that's 2 out of 500. That's very low uncertainty, very low uncertainty, very low uncertainty there. So I'm just going to do a check here. I'm going to add up these guys and see how close they come to the number 1, 0.986. That means that the sum of these coefficients is roughly equal to 1. And that's just matching this unknown, which supposedly just has those 3 ingredients. So that's pretty darn good. So there is that. Now let us convert these guys into percentages. Okay, and we'll add a digit to them. Yeah, maybe add 2 digits. Yeah, there we go. There we go. That works. Add a couple digits to the percentages, right? Excelente. So we'll save this guy, and I will go to this Raman. There you go. Okay, this is going to be the Raman Workup example. Okay. So now what are we going to do with these data? So we have the coefficients, right? Now we need to modify the graph a little bit so that it shows these various aspects. So what I'm going to do now is I'm going to make component spectra. All right? The way that, and I'll show you how I'm going to do that in just a second. So I'm going to move this over here a bit. Now I'll make a skinny column there just to separate these, right? I'm going to say component acetone component toluene and component ethyl acetate. Right? And now, after that, I'm going to make the model sum. Okay? So component acetone is going to equal that percentage, F4, times the acetone value, right? Oops, I'm going to delete this stupid column. I'll put it back later. Now this guy, I'm going to double click there, and that should scatter that guy all the way down to the bottom, right? Okay. Component toluene is going to equal this guy, F4, times this. That guy down there, and component ethyl acetate will equal this guy, F4 times this. So let me check these. Ethyl acetate, toluene, acetone. Great. So now toluene here, I'm going to take it. I'm going to actually take it. I'm going to move this to that guy, and I'm going to move that guy there. I'm going to grab this guy, ethyl acetate. I'll move this guy over here. And now I've got to get acetone. And acetone, I'm going to move to component acetone here. Right? So I'm actually now add in a little column there to sort of separate them. All right. So how does that look, guys? Looking better. Now you can see how when you add them up, these components make the whole, right? So this is the unknown, right? And that's the sum of the component acetone and the component ethyl acetate. Oops, no, sorry. Component ethyl acetate, right? Okie dokie. So let's just change this a bit. Now let's change the horizontal axis. We're going to highlight just these peaks in here. Well, maybe up to 1525. I don't know. Let's see. Let's go from 5. There we go. Decongest things just a little bit more. And let's make this guy max out at 1000. Or 10,000 rather. And that's looking good. That's looking good. So let's make one more column here. We'll make 2 more columns. A model sum. This is going to equal the sum of these guys. Right? And then we're going to make one more column called the residuals. And this is going to equal the model sum minus the unknown experimental spectrum, right? All right. So here's this guy, right? This shows good agreement. So now let's make a copy. Well, let's actually we'll add some cosmetic stuff to this, then we'll make a copy. Format. Well, let's go design, add element, titles, horizontal. going to be shift in centimeters inverse. Going to do a control 1 here. Oops, where is that? Okay, I'm not going to do control 1. I'm going to go home, font, oops. My control 1 dialog came up in a weird place, I think. Didn't know where you are, Mr. Control 1. Where are you? Where are you? Oops. Oh well. I'll do it here. So 1, 2, then we'll do control 1. There we go. And then we're going to superscript the -1. There we go. That's, reciprocal wavelength in centimeters called wave number. It's proportional to frequency, it's proportional to energy, right? It's not linear with a wavelength, but okay, whatever. So now we're going to design this guy, add chart element, axis titles, primary vertical. And this is going to be intensity. In arbitrary units. Okie dokie. All right. So now I'm going to take this legend guy, add it to the white space over here. Take this, expand it a little bit vertically. Oops, there we go. And that one is pretty close to done. Expand it just a little bit more there. Okay, so that's acceptable. One thing we could do here is we can format this, give it a fill. That's sort of like, yeah, let's give it a nice gray fill there. All right, so there's that guy, right? Now let's actually copy this. And let's change things around a bit. Let's not look at the components anymore. Let's look at, for example, component acetone. Let's change that to model sum. Okay. And let's see here. Component toluene, let's change that guy to residuals. Okay. And then, so here, I should say residuals now. Oops. Okay, oh, so I didn't get the component toluene, right? So component toluene, let's kill that guy. All right. So now we've got the model sum, the residuals, and the unknown. All right. So what this shows us is how good the overall fit is, right? And where there's any uncertainty in the fit, right? So there is a glitch right here, which indicates a slight frequency shift in the in this large peak at like this 800 or this 780 wave number peak. So that's slightly solvatochromic, we might say. It has a slight shift in wavelength as a function of frequency. And there's another similar shift over here, right? But basically, this looks really good. We might actually want to put this on its own axis. So we can put this on a secondary axis there just to sort of illustrate the differences. And we can make this guy maybe, well, anyway, we'll leave that as it is. Not going to mess with the color. So here is the report, right? Ethyl acetate, toluene acetone. This is the sum, right, of these guys. And this is what we want from the analysis. We want 45, 3, and 48% there. And that is all we need to do here for the basic data analysis. There is a part where we want to identify peaks that are unique to one of the spectra. So there is a peak here at 631. So let's do this. 631, 631, and we can say 0 and 10,000. Let's go ahead and we're going to format, design, select data, we're going to add. This is going to be a oh my gosh. A unique marker 1. The x values will be here, and the y values will be here. Okay. There's that guy. This peak, unfortunately, is not unique, right? This peak here is, you know, there's a lot of them that don't have toluene, right? But here's sort of a wavelength that's more selective for acetone and more selective for ethyl acetate here. So why don't we say 1425, right? And then say 1468. Okay, so let's add a marker here. Okay, I went that's a little bit too high. How about 14? There we go. It's a little bit better. All right, so I found some peaks. You guys can probably do better than me on this. So that is all we really need to do with this mixture. So excellent work so far. Then you want to answer the questions in the report and then turn in the questions and this spreadsheet together and have this table in the Word document that you make the mini report on. All right, guys, thanks so much.